Okay, these two triangles are similar to each other by angle. So if you think of this whole side is 24 and this nugget AH is X, then this small side of the little triangle AY is going to be 24 minus X. If you think about like if this whole thing's 24 and if this was 10, this part would be 14, which is 24 minus 10. That's where that comes from. If you know part, you can subtract the part from the whole. So now we have the little triangle and the big triangle, and 16 plus 22 is 38. And so now we can set up a proportion, 24 minus X over 24 equals 16 over 38. I'm going to simplify the 16 over 38 to get 8 over 19, just for smaller numbers. Cross multiply, you'll get 19 times 24 minus X equals 8 times 24. If you distribute, 19 times 24 is 456 minus 19X equals 8 times 24, which is 192. Then you subtract the 456 from both sides. You get negative 19X equals 192 minus 456, which is negative 264. Divide by negative 19. And you get 264 over 19. That's actually fully reduced. So you can keep it like that, or you can turn it into 13 and (17 over 19). Either way. Both are totally correct. Honestly, do this one because it's easier. Why do more work than you have to? Okay, second question. I'm going to do the colors thing, which I highly encourage you to do. So I'm going to call this my purple angle, and this is my purple angle. And then this is my green angle, and this is my green angle. I'm going to draw those three triangles separately. I'm going to do big, medium, small. I'm going to put the green angle at the top, purple angle at the bottom. So on our big triangle, across from the green angle is X, across from the purple angle is Y, and then the hypotenuse is 100. On this small triangle, across from the purple angle is Z, across from the green angle is whatever 100 minus 64 is, which is 36. And then the hypotenuse across from the 90 is X. And then on this triangle, across from the purple angle is 64. Across from the green angle is Z. And then across from the hypotenuse, the hypotenuse across from the 90 is Y. So in this situation, I would go check and see if you can match up any numbers. So I have X and 36, and then I have 100 and X, so I think this is going to be my money. I'm going to set up a proportion with my X's first. 100, X, 36. So I can do X over 100 equals 36 over X. x over 100 equals 36 over x. Or I could do x over 36 equals 100 over x. Either way, I'm going to cross multiply and I'll get x squared equals 3600. And so when you take the square root of that and then you simplify it, you'll get x is 60. So now you know that x is 60. So now I go back to this triangle and I have 2 out of the 3 side lengths, and so now I can just do Pythag to get z. So z squared plus 36 squared equals 60 squared. Z squared is 60 squared minus 36 squared, which is 2,304. And when you take the square root, you get 48. So z is 48. And then if z is 48, then you can go do Pythag on this triangle to get y. Or since we know x is 60, you can do Pythag on this triangle to get y. You should get the same answer. I'll do it on the big triangle just because those look like easier numbers to deal with. Y squared plus 60 squared equals 100 squared. Y squared equals 6,400. And so y is 80. So you should get the same thing over here. So essentially, you set up one proportion. Basically you would want to like compare, like I also could do like a proportion with my y's. I could do y over 64 equals 100 over y. That would have worked. You just want to find the 2 triangles that both have a y and see if you can set a proportion. Or when we had the z's, we could have done z over 64 equals 36 over z. Z over 64 equals 36 over z. That also would have been a proportion we could have set up. So there was lots of options on what you could do. Yeah, once you set up your proportion, though, then you could just do Pythag on all the remaining triangles. All right, on this triangle, special right triangles problem, there's 3 triangles. We're going to start with this one because we actually know one of the side lengths. I noticed that these 2 angles are congruent. And since this is a right angle and those 2 angles are congruent, it's isosceles, making it 45, 45, 90. So if I think about 45, 45, 90 triangles, it's S, S, S root 2. So I'm going from my hypotenuse to my short side, so I have to divide off that root 2. So I'm going to take 4, divide it by root 2. Uh-oh, can't leave a square root in your denominator. You have to rationalize it. Do that fancy one, root 2 over root 2, which gives you 4 root 2 over 2, which gives you 2 root 2. So this side is now 2 root 2. Okay, so now we have a 30, 60, 90 special right triangle. And so now I have completely different ratios. Across from, this is the 30-degree angle. Across from the 30 is S, across from the 60 is S root 3, and across from the 90 is 2S. So I know my hypotenuse. I'm going from the hypotenuse to the short side, so I'm going to divide it by 2. So my hypotenuse is 2 root 2. I'm going to divide it by 2, so those 2's cancel out. And now my S, my short side, is root 2. So this side's root 2. And I'm going to redraw that 30, 60, 90. My hypotenuse was 2 root 2, so now my short side is root 2. And so to get from the short side to the hypotenuse, you're going to multiply by root 3. So root 2 times root 3 is root 6. So this side right here is root 6. And so now our grand finale is this triangle, which is also a 45, 45, 90 triangle because it's isosceles. Sorry, my active board is being pretty silly and it won't let me change the color of the pen, which is so annoying. There it goes. So our hypotenuse is root 6 These are 45, 45. So S root 2. So I'm going from the hypotenuse to the short side. I'm dividing off that root 2. Root 6 divided by root 2. I can just divide those numbers inside the radicals and get root 3. So S equals root 3. So X, that missing side, is equal to the square root of 3. And then finally, find R, so that's a sixth of the distance from S to T. So S is over here at negative 8, 4. And T is over here at 10, negative 6. This is S. And this is T. So to get from S to T, we're going to, again, S to T. Pay careful attention to what order, which point you're going from towards which point. So we're going from S towards T. If I was going from T towards S, it'd be a completely different situation. From S to T, we're going to the right and down. From T to S, we're going to the left and up. So from S to T, I'm going to go to the right a certain distance, and then we're going to go down a certain distance. So we're starting at negative 8, and we're going from negative 8 to positive 10. So that's a total of 18 units to the right. Well, I only want to go a sixth of it. A sixth of 18 is 3. So we're going to go 3 units to the right, which means we're going to add 3 to the x coordinate of S. So we're going to go 1, 2, 3 spaces to the right, which is going to put us at negative 5. Then I'm going to repeat this process for my y coordinates from 4 to negative 6. So I'm going down 10. Well, I only want to go a sixth of that, so that's negative 10 over 6, which is negative 5 over 3. So that means I'm going to subtract 5 over 3 from my y coordinate. So I have 4 minus 5 over 3. And that means I need to find a common denominator. So that would be 12 over 3 minus 5 over 3, which is going to put us at 7 over 3. So it's negative 5, 7 over 3 for my new coordinates of R, which is a sixth of the distance from S to T.